Good afternoon and welcome to you all to this special webinar, day 2. We are in day 2 in celebration of Open Education Week 2024 at NDU. Today, we will embark on a journey to explore the transformative power of open education resources in the fields of physics and mathematics. As we continue to champion open education at our university, NDU, in Lebanon and in the Arab region, today's session promises insightful discussion that not only underscore the value of accessible learning materials, but also illuminate the impact of OER in two crucial departments. Our first speaker, an expert in the field of physics, he will delve into the fascinating world where open education resources have been harnessed to enhance the learning experience of our students. Following Dr. Bassem Sabra, who is the chairperson of the physics department at NDU, we will have our second speaker, Dr. Nakad, who will take us through the dynamic landscape of OER in the mathematics department, where he will shed light on innovative practice and the far-reaching benefits of open educational resources. So without further ado, let us embark on this enlightening journey. Okay, and the floor is yours, Dr. Bassem.
Thank you, Dr. Baroud, for the nice introduction. Oh my God, we started questions. Somebody raised their hand. Haven't started yet. Let me share. And I want to share.
Maya, you have a question? Why you are raising your hand? Okay, maybe by mistake.
I want to share my screen.
Yes.
Okay, here, let me see. And I want to share Edge.
Yep, here we go.
Okay, can you see it?
Yeah, that's fine.
Okay. My presentation will be basically show and tell. I want to share with you the exciting world of PhET simulations. So this started, they are PhET simulations. They started in physics, but then now they have simulations in chemistry, math, biology, earth sciences, and all of that. The nice thing about them is that they are free, and as I will show you, they are also open. Okay, so yes, there are things that are free. For example, Stellarium, which is a planetarium software, it's free. The free version of it comes with limited functionality, but as far for an ordinary user, it's great, even in its free version. But here, it's free and open also. We'll get to that later. So I'm going to show you things about physics. It contains a lot of teaching resources and activities that you can create and post on this platform, depending on, you divide it by level, for example, for schools, for university, undergraduate, beginning undergraduate, advanced undergraduate, graduate, and so on and so forth, depending on what you want to do. Let me start by showing them first, and then I will, of course, I'm going to talk about physics because that's what I'm familiar with. So here's physics. So basically, it contains a lot of simulations, about 56 in various fields: mechanics, quantum mechanics, electricity, light and optics, and stuff like that. Now, recently, over the last several years, they have been upgrading their simulations to be HTML5. Before, they were mostly Java and JavaScript, but Java is no longer, or Flash and stuff like that. They have almost 100. But for these ones with Java, it's with HTML, it's about 56. Now, the beauty about these simulations is that you can use them as a virtual lab in your classroom. Okay, you can use them as a virtual lab in your classroom. So for example, when I'm talking about Kepler's laws in astronomy 201, let me turn on this assignment, this simulation. So the first law says that all planets go around the sun in ellipses with the sun at one focus. So instead of showing the students static pictures on PowerPoint of ellipses and planets and orbits and whatnot, you can go start with this simulation, show them how the planet orbits. You can change the size of the orbit, you can change the velocity of the orbit, and experiment, basically have your sandbox, your solar system sandbox in class. You can experiment with they ask you, okay, what they students usually like this a lot. They ask you, okay, what happens if I give it a very short, very small velocity, if I decrease the velocity, and at some point you can see that as the velocity is going down, you can guess what will happen. It's gonna crash, and students love that when they see crashes. So you can control the velocity, the speed of the planet around its star. Can show the gravity forces. It can put the speed, and you can use this also to show them that the forces. The reason why these later on, when you discuss that, when you talk about Newton's laws, that Kepler's laws are basically a consequence of Newton's laws. So you can show them the forces also, and you can show them also just from this simple simulation. Let me remove the gravity and keep other things. I want you to notice something here. I want you to pay attention to this number here, the speed of the planet as it orbits the star, and notice what it happens. In particular, I want you to note the speeds when it's far from its sun, and the speeds when it is close to its sun. So here it's around here, it was around 11. Here it's jumped to 65. So we can develop Newton's second law from just playing around this simulation. So instead of just standing in front of the students, showing them graphics and the usual PowerPoints, you go into actual solar system building, and you can experiment with develop these laws in front of them. Another one that I also like, I'm showing things that are eye-catching. There are many things that are also very important, but for the purposes of this talk, they might be a little bit staid. For example, where's this thing here? Nowadays, this is in electricity. These days in winter, we are wearing wool and nylon and whatnot, and we have carpets. So if you rub your foot on the carpet and shake somebody's hand or touch a doorknob, what will happen is that you'll feel a spark. So we go take this, start with this, instead of just talking about things in the class. I can start with this simulation here, and tell them, okay, if you're not touching anything that's conductive, nothing will happen. You don't feel anything. But if you touch anything that's conducting, like a doorknob or another person, you feel that electricity, small spark. And that's because you are transferring charges from the carpet to your foot and to your body, and then you basically get charged. Can take it a step further and with another app, with another simulation. What was next to it? What's that? What is it? Oh, the balloon thing. Again, starting from the students' everyday experience to build up later. If I want to talk about Coulomb's law, for example, I don't start with Coulomb's law. I start with a balloon and a sweater. So before rubbing the balloon on the sweater, the balloon is not attracted by the sweater. After I rub the balloon on the sweater, so first I start with no charges. I don't show any charges. Okay, I don't show any charges. Then I do the rubbing action on the balloon and the sweater, and then I leave the balloon, so it gets attracted to the sweater. So at this stage, I stop and ask the students, so what do you think the reason is? What's going on there? So they start, and of course, they've heard about charges in school, so they start saying something about, okay, it gets charged, whatnot. So I tell them, all right, let's see what's going on here. Let's put on the charges. Matter is overall neutral, equal positive and negative charges. When we rub the balloon on the sweater, what's happening is that the balloon will gain a net negative charge, and the sweater location where you are rubbing the balloon on loses its electrons, so it becomes positively charged. Positive and negative attract. So from this, these are opposite charges. So that's how I developed that. It's not just boom, 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 going one after one factoid after the other. No, I go and develop things in this way, starting from there, using these PhET simulations, starting from their everyday experiences, and then putting it into the context of physics. I can get two balloons. Okay, let's see what happens when I get two balloons. I'm going to rub this here, and I'm going to rub this here, and we'll see that the balloons will start repelling each other because both of them picked up the same sign of charge. So that now they repel. So from that, we develop the fact that same charges same charges repel, opposite charges attract, and we go into all the other business. I can even follow it up with, I mentioned Coulomb's law. I can even follow it up with, sure enough, yes, there's a simulation for that, but I'm not going to go into it here. Yes, there's a simulation for that. It's a Coulomb's law simulation. Of course, there are things about trajectories. Students also go crazy about that. I can't resist but show you this. Now that we are on the brink of war. So you have a cannon, and you can play around with the initial speed. And if you have a target, you want to hit the target, and fire the rocket. Let me see here. And it marks the trajectory of the projectile. You can change things here, and then fire it again. Oops, no. And you have students usually at this point are just, the whole class erupts with higher or lower, just, taking ranging data just to hit it. And then you can go and work the equations instead of just the boring, the usual boring physics class in which, or the stereotype of a boring physics class in which you just write equation after equation on the board. You start with something here, and you find, and you go write its equations. That breaks basically the barrier, or the entry barrier for students. You can treat other advanced topics here. You can change the shape of the projectile. So things that are more cone-like will have, of course, will have different trajectories than things that are rounder. And that's called it. So here it's the same everything, but I changed the shape of the projectile, and here you see that it didn't travel as long. So if you make it very aerodynamic, it can go farther, even if initial speed is the same and the angle of at which you are launching it is the same, just by changing the shape of the projectile. And from this, you can go into, you can basically introduce the concept of air resistance and how the shape of the projectile changes the flight characteristics. I can go on and on talking about these.
Okay. Let me stop you here, Bassem.
Yeah, but just one thing. Just
Okay.
one thing. So these, as I said, are open, so they are under CC BY, CC BY, and they have their the thing that they'd like people to use if they are sharing it. So it's basically Fauzi, this is the most permissive, right, of these common.
Right.
Creative
It's
Commons.
the most open license, CC
the most
BY,
open
right.
license.
Right.
Now they make their source code available, of course, but if it's not for the faint-hearted. So according to what they say here, I'm just going to say a little bit, talk a little bit about this and stop. That it requires, assuming that you are a top simulation developer. So if you want to develop something similar to this using their source code, it requires 160 hours of design, 500 plus hours of software development, 40 hours of testing. That's what it takes them if they are developing new simulations, and they have been doing that for almost 15 years now.
Well, actually,
so
Bassem,
needless to say,
this is Bassem. Let me say here, this is the beauty of OER. You know, you don't have to reinvent the wheel and spend hours.
Exactly,
You know,
but even with that, if you want to make good quality, high quality OER, it takes time. It's not,
right.
oh, I can just type in any OER that I want. It takes time to have a quality OER. Otherwise, we can all just, you know, start putting our first computer code online, and we can say, oh, that's OER. Well, who cares if it's not? And software developers know what I'm talking about. If it's not a good product out there.
Okay, let me stop you. Let me stop you here, Bassem. And well, you know, like you gave us some example of simulation activities which are free and open under a Creative Commons license that you are using in your classes. But we know that also you are using open textbook in your classes. Can you tell us, you know, 2-3 minutes about, you know, the open textbook initiative that's happening in your department?
Basically, I talked about this last year, so this year I did not want to go over it again. So basically, what we try to use, we try to force, or not force, maybe that was the wrong word, push instructors to use textbooks, especially the entry-level textbooks from OpenStack's website. It's textbooks written and curated by Rice University in the US. Again, many subjects. So in sciences, they have astronomy, chemistry, biology, and of course, physics. We have gold standards in physics. So for example, if you tell any physics professor in an American university, Resnick, Halliday, and Resnick, they know exactly what you are talking about. So this OpenStack's website, they have these 3 volumes: physics, volume 1, volume 2, volume 3. They correspond almost chapter to chapter, and the breadth and depth, they cover the breadth and depth of Halliday and Resnick, which is, I think, published by Wiley. And you know Wiley prices, yeah, Wiley. But here students can have it for free. And it's regularly updated. It's not that they threw something online several years ago. I think this is their 2nd edition. Many, for example, college physics, they are through their 2nd edition. I know astronomy, they have their 2nd edition, and physics also, I think they are I'm not sure if this is their 2nd edition, but they probably they will release their 2nd edition soon.
Okay,
so
and
it's not something that's static that they threw over and just forgot about it.
Yeah, and this is have a huge benefit for our student. You know, the first one is about cost, so our student don't have to pay for expensive physics textbooks. and of course of high quality, because those are peer reviewed and they are curated by Rice University. And one thing I want to add here to what Bassem was saying, that those open textbooks can be adapted. Faculty member can pick up which chapters they want to use in their teaching and learning, so on and so forth. So before,
and it comes with a question bank. Sorry, I forgot to say that it comes with a question bank. If you, I used it in astronomy. It's if I gave them my university email, I logged in with my university email. They double check that I'm a professor at university, and I have an instructor's account. So they have a question bank. They have slides. They have. Oh, I haven't.
All the resources.
Many resources.
Right. Bassem, before we move to our second speaker, Dr. Roger, I have a question, from your experience, and since you've been using OER for a long time now at NDU, in what way do you foresee the integration of OER evolving in the future of physics education, and what are the challenges that might arise, in your opinion?
I think OER is here to stay, and it's a natural scheme of the evolution of things. Physics started as OER, but this archive.org, the preprint server, started with physics. A lot of data is online and available, and so that's the natural scheme of things. And in many cases, you have professors putting their lecture notes and exams online. So it's moving in that direction. The challenges that I see is being or having a way to do quality control and quality checks. Because I see it sometimes with students, they want to have extra materials, so they think if they watch YouTube videos, that will make things better. And at some point I told them, no YouTube videos, because there's the good, the bad, and the ugly on YouTube videos. So if they happen to stumble upon a bad video, then good luck changing their misconceptions. So at some point I had to step in, draw the line. No YouTube videos. Don't ask me about them. If you want to study, this is the textbook I'm providing. We're solving. These are the examples. These are the whole assigned homework problems. And if you have questions, come to me. Yes, there's a lot of open educational resources out there, but the main challenge, in my opinion, is quality.
The quality. Okay, thank you, Bassem. Thank you so much for. I will leave the questions till the end from our participants. So now moving to our second speaker, Dr. Roger Nakad. He is the Dean of the Faculty of Natural and Applied Science, and previously the chairperson of the Mathematics Department. He will take us through the dynamic landscape of OER in the Mathematics Department, and he will shed light on innovative practices and the far-reaching benefits of open education. The floor is yours, Dr. Roger.
Thank you, Dr. Baroud. Thank you, Dr. Sabra, for the presentation. I will start to explain or to give a brief on how we started to use OER in mathematics back in 2018, if I remember well. So the idea at the beginning was normally mathematics is not liked or hated by all type of students, business, humanities students, even science students. They try to avoid taking math courses. We are facing this problem even if we have a math courses into the LAC curriculum. So this is understandable in a way, because our role here is to change this image, and maybe not going just into formulas and calculation, but instead of that, let our students analyze and use arguments. And maybe here OER came to say, okay, maybe we can use OER. So we decided back in 2018 to use OER to revamp the Calculus 2 course, which is a remedial math course at NDU. We had several problems in this course. We are still facing some, of course. But this remedial courses is taken by, I mean, we do offer a lot of sections per semester because this courses is needed for engineering students and science students as well. So the idea came because we have seen a lot of problems is to develop or use OER to build and to design the Calculus 2 course for our math students. So what have been done since 2018? So we revamped the course in a way to have easy access via Blackboard and personal websites. We have revamped all sections using resources which are under CC licenses in terms of lecture notes, exercises, a video. I will show you in a few seconds some samples. We have used, of course, OpenStax, MIT, Khan Academy, and so on. We have not only used available resources, but we have created some new videos, lecture notes. Here, for example, one of the things that I can show you is a video. Maybe I look ugly here, but it's okay. This is a video, thanks for the IT office, that it was prepared to explain a section. This now it's under CC license. It's now available on YouTube. So we are not only using OER, but we are also developing our OER material. So we were able to post it on YouTube. I don't, maybe you don't have the time to watch the video, but maybe I would like to just show you use the use substitution method. So just the way of explaining things using using the use substitution method, using the specific topic, using the resources that we have at NDU. So here again, thanks for the whole team who provide us with the all technical facilities to record the videos and develop material. Okay, sorry. Okay, so besides registering some video lectures, we gave projects, and even if it is a remedial course, we gave a project to let the students see what are the application of mathematics in real life. So, for example, one of the beautiful application is how we can use mathematics in the Formula One, how the drivers of Formula One use mathematics to get the exact angle to turn with his car and so on. So students definitely love these applications. And the last thing we used also, we have adopted open badges system. This was at the introductory level. Maybe Dr. Baroud can give later on insight on how the open badges system was implemented. For the remedial course Calculus 2, we gave to our student badges. We provide them badges via Blackboard. So this was directly implemented. So if they do good in a section, or if they master some expertise, they will get a badge. So accumulation of badges definitely will increase their knowledge and the grades of and their grade in the course. What else has been done? Of course, we have introduced some OER readings to make math fun. As example, who's Newton, what is log, what is exponential, and so on. I have a list of samples that I'm going to show you. We have, of course, used some YouTube. Besides developing videos, we have also used YouTube videos, which are of course, under CC licenses. We have provided links that we created or links that already exist to have feedback on a specific topic or feedback on a specific section. So maybe at the end I can show you some samples. So what was, let me tell you briefly what was the impact at the end. So the impact, first of all, as instructor, okay, so it was challenging for me, because I mean all material are under peer review. So this is a personal gain for my reputation as instructor or the reputation of the university as well. I have been exposed to other teaching approaches, definitely, when we implement OER in Calculus 2. For the last item, we encourage more NDU and FNAS faculty member. I believe one of them is with us, Mrs. Maria Zugbe. She took Calculus 2 after me, and she gave it for 1 or 2 semesters using OER. Thank you, Maria, for your effort. And this is the impact on us as instructor. On the students, as said by Dr. Baroud, we have reduced because the Calculus 2 or Calculus 3 or Calculus 4 book is around $150. The ebook is around $80. So you can imagine how much we decreased the cost on the students. Calculus 2 was chosen because it is a prerequisite course for Calculus 3, Calculus 4, OGE, and the series of calculus course. So this one or this course stayed now as a reference and an open reference, free open reference for all the other math courses at NDU. Example, a student in Calc 3 was not able or we would like to come back to some material in Calc 2. He has full access to all material of Calc 2. A student at risk, I will give later on the statistics. We increased the percentage of retention for at-risk students, and students now are more interested in the field of mathematics or the reason behind all the formulas that we are doing or the calculation that we are doing. So, for example, the open badges played a big role because students were motivated to give more. They can link mathematics to other fields. As example, I said the Formula 1. They discovered the beauty and the utility of mathematics, and this helped them, of course, to get over the fear of mathematics. So another improvement or impact that it's not written on my slides, we can see now students are more interested in math courses, which are liberal arts curriculum courses. So they need to see more application because some of them took Calculus 2 already, and they have seen how the application could be or how fun is implementing OER in Calculus 2. Definitely, we have impacts on NDU. The withdrawal rate that we faced previously has been decreased. For the time being, we are seeing more increase in the number of W, but it's not due to OER or to NDU because we have a MEHE problem. So this is different. So this improved recruitments of students at the level of remedial courses. And again, it decreased the withdrawal rates. And it is now an open course for the whole university. Most of the students at the faculty and the faculty of engineering will take the series of calculus. So this basic course is again an open and free course for all these students. Some results, definitely 75% agreed and 25% strongly agreed that they enjoyed learning Calculus 2 using OER instead of a book. They were, in a way, they can write mathematics better. They are more independent and more interested in the topics. They are exposed to many new abilities and skills. For example, when we used or when we gave examples of the Formula 1, students were divided into groups, and then this enhanced the communication between the students, the problem-solving skills, and the critical thinking as well. The withdrawal rate, as I said, decreased. Currently, we have a MEHE problem. That's a different issue. The enrollment intensity has increased. Yes. I mean, we can see that some students are not required to take Calculus 2, but nevertheless, they prefer to take Calculus 2 before taking the other series of calculus courses, just to have a solid background. And they know about OER in Calculus 2. This makes their choice, if you want, easy, and this is gives them confidence for the other series of calculus courses. At the end, and before I give some samples of what has been done beside the video, I would like to thank Dr. Eid, Dr. Baroud, Dr. Abdel Noor, Dr. Azze, Sahar, Brigitta, and all the whole computer center staff and member. Who, before finishing and giving some samples, these are when we circulated the survey to our Calc 2 students. I like these two statements, if you want. I went from being horrible in integrals to actually evaluating these. Another one, finally learning how to properly use the provided formulas as well as figuring out where my path is directed. These are the feedback of two Calculus 2 students that I pick or I choose or I prefer. So now if I have time, Dr. Baroud, I would like just to beside the video.
Yeah, go ahead, Roger.
So these are some samples. Of course, we have used YouTube videos already under CC licenses that make our learning journey simple and easy accessible. We definitely use examples and links from which are, if you can see here, they are already licensed under CC share alike. So we make sure that we are using references that they are peer reviewed and they are under CC as well. From Wikipedia sometimes, if we want to have some history about Newton or about specific results and so on, again, all of them are checked to be under CC. Besides using Khan Academy and MIT and so on. So we didn't limit ourselves to one reference. We used variation of references from creating our own to using the existing one. That's it from my end, Dr. Baroud. I stopped sharing and leave the floor to Dr. Baroud or the other attendees if they have questions.
Yeah, thank you, Dr. Roger. Excellent presentation, you know, where Dr. Nakad took us around, you know, what's happening in the mathematics department, their experience. Moreover, you know, he talked about, you know, the student experience, you know, how effective, efficient was the use of open textbook, OER, and stuff like that, you know, how positive it was. So thank you, Dr. Nakad. I have a question or two, but I will leave the floor now for people attending the webinar. If you have any question, please, for both speakers, you know, Dr. Nakad and Dr. Sabra, please raise your hand and we're ready to answer your question. Amin Musa, تفضل دكتور أمين.
Yes, hi. Thank you, Dr. Baroud. Thank you, Dr. Nakad and Dr. Sabra for these quite interesting presentations. I have a question for Dr. Sabra regarding the simulations that you've displayed. So are these simulations predefined and preset, or can the students build their own simulations? And here I'm thinking of back in the days when I was doing my master thesis in computer science, I was working on wireless sensor networks. And I remember the headache of developing wireless sensor networks. Now, looking at how easy things have become, I'm thinking, can I, for example, develop my own sensor network using those simulations, or are they preset and predefined?
No,
and
they
students
are
can just
preset.
play with the parameters?
They are preset.
Okay. There is no way for students to build their own.
I don't think at this level.
Okay.
Not, this is graduate, undergraduate level. I don't think they can build their own. There are other things in which students can build their simulations. Like there's a software called Easy Java Simulations where you can go and start bringing things together and you build it, but it's not at this level. This is used in I use it as a virtual lab in the classroom. Here we have physics classes and lab courses. And many times things don't go hand in hand. So you want to facilitate how you deliver a concept. So you want a lab. So that's my lab.
Okay. Interesting. Thank you.
Okay. Thank you, Dr. Amin. Any other questions for our dear speakers? Any other questions? All right, so I have a question, like for both of you, I was thinking about how can well actually it's physics and mathematics departments are under the same umbrella, but my question is how can the physics and mathematics departments work together to create a more comprehensive OER ecosystem? Okay. And have you done this homework, of the collaboration thing between the mathematics and physics department?
No, we didn't do that, but maybe it's a good idea to think about it.
Yeah.
For the time being, OER, from what I understood from Dr. Sabra, the OER for the time being is implemented in Astronomy 201, right, Dr. Sabra, which is a liberal art curriculum course. That's
Yes.
from one side. And from my end, it's implemented in a remedial course for the reason mentioned in my presentation. So there is no, for the time being, any collaboration but that could be for the future. Yes, why not? I see your point.
Yeah, well, I guess, the OER movement or open education movement is a big movement worldwide nowadays. And it has, as we are seeing and witnessing, that it has a lot of advantages for our faculty member, for students, at all levels. Okay, so I guess what we need more training. We need more champions on campus. I do believe we need more champions like Dr. Roger, Dr. Bassem. Okay, so that we build this ecosystem, sharing of knowledge, so on and so forth. For example, let me just tell you, there is this technology which is called H5P today. H5P, this is where a faculty member can they can create their own activities already. Like there are so many thousands of activities available in all majors. They have on their platform around 50 type of different activities where faculty member can take those activities and they can add, for example, one activity is taking a boring video from YouTube under an open license and making this video an interactive and engaging video where the faculty member can by himself without the help or the need to technical support, he can take this video and add some engagement and interactivity on this video, and then he can put it on Blackboard or on Moodle or whatever, or on any platform he needs. This is something we will be doing in the future. Right now, we are working on the OER policy, and Dr. Sabra is a member of this OER policy. And almost, this policy is done because the policy also is an important document to have at the university level, so that our faculty member knows that there is a policy for OER. Actually, OER is in our strategic plan. It is integrated into the university strategic plan, but still need the policy. And hopefully, as you all know, there is a committee, OER committee and digital badges committee, since Dr. Nakad mentioned the digital badges, where we will be designing or formulating a policy also about how to use badges and digital badges, so on and so forth. And this is the next job of the committee, to produce a document for digital badges at NDU. If we have no other question, I want to thank Bassem. I thank you, Roger, for this being with us today, and we'll see you all hopefully tomorrow, where we're gonna witness and talk about faculty members who have used the OER in the humanities department, and more specifically in the public speaking course. Thank you so much for attending today's session, and let's keep moving forward. Thank you so much.
See you. Bye. Thanks a lot.
Thank you so much.